Pre-calculus students to the homework help video. Please get your books open to page 473. We're going to look at numbers 83 and 85. And then we'll move on to page 488 here in a little bit. Have your homework out, your calculators, your pencils, and please be ready to work. All right, sorry about that. Quick drink of water, and here we go. Let's start off with taking a look at number 83. An airplane flies 150 kilometers from an airport in a direction of 120 degrees. How far east of the airport is the plane, and how far south? Well, what I have taught you to do is just go ahead and get a picture of this direction and kind of what we're looking at here. So there we go. And the airplane, remember, you always start on the positive y-axis and you rotate clockwise, okay? So please don't forget that. Now we're going to go 120 degrees. So we rotate from here to here is 90 and then 30 more. So there we go. Here's where the airplane took off right here at the airport at the origin, and it's traveled in the air at a direction of 120 degrees until it gets right here. Now what is the distance of this line? Well, it's the distance the airplane has traveled. And the airplane has traveled 150 kilometers. So we'll put 150 kilometers. Now, we're looking for how far east of the airport is the plane. So we know we're looking for this direction here. And how far south, so downward. So we basically, well, it's actually not basically, we have a right triangle. So what we're looking for is how far east is the plane from the airport and how far south is the plane from the airport. So we'll put an S here. Now, if I rotated 120 degrees like the original problem said, then that means from here to here was 90, and this little bit right here inside the triangle has to be 30 degrees. So off to the side, I'm going to go ahead and draw a right triangle that resembles this triangle somewhat. And I'm going to put 30 degrees here, and the letter E here, and a right angle here, and the letter S here, and then 150 right here. Now, I'm going to go ahead and find south first. No certain reason, I just kind of feel like it. So, if this is the angle I'm dealing with, I go straight across. This is my opposite side. This is my hypotenuse side, and this is my adjacent side. Now, you definitely don't want to use, you do not want to use opposite and adjacent because you would have two unknowns. So I'm going to use opposite because I'm looking for south, and hypotenuse because I know the length of the hypotenuse is 150. So, what trig function uses opposite and hypotenuse? Well, students, that you should know, that should be sine. So sine of 30 degrees equals opposite, which is S, over hypotenuse, which is 150. Very good. Now, anytime you have a trig equation and you're missing part of your fraction, I've taught you to multiply both sides by the bottom of the fraction. So I'm going to multiply the left side by 150, and I'm also going to multiply the right side by 150, thus leaving me with S. Now, please don't type this into your calculator, 150 times the sine of 30. Remember your special triangles that we have? This is 30, this is 60, right angle, 2, 1, square root of 3. You should really know those by now very well. Well, I know the sine of 30. Use your special triangle to find it. The sine of 30 is opposite over hypotenuse, 1/2. So 150 times 1/2 would give me S. And 150 times 1/2 is 75 kilometers equals south. So now I know how far down, how far south the airplane is from the airport. The answer is 75 kilometers. And I always check, let me look in the book, I always want to check and make sure I've gotten the answer right so we don't come down to the end and it's incorrect. And that is correct. Alright, now we're going to have to find next the east, side E. How far east is the airplane from the airport? And students, if I know two sides, which I do, see this S right here, I can now cross that S off and put 75 because I found that right down here. Let's use Pythagorean's theorem. I mean, E is one of your legs, so E squared plus your other leg is 75, so 75 squared equals your hypotenuse squared, 150 squared. Now I hope I don't run out of room here. 75 squared, let me grab my calculator real quick. 75 squared would be 5,625. I'm probably going to run out of room. And then 150 squared would be 22,500. So I'm going to draw an arrow. 22,500, and that would go right there. Now, let's subtract 5,625 from both sides. And if you do that correctly, you will be left with E squared equals 16,875. And now let's take the square root of both sides. The square root of E squared is E, and the square root of 16,875 would be 129.9. So I'm going to go ahead and just put 130. So now we know how far east the airplane is from the airport. It's 130 kilometers. Not too bad. Let's continue on. Excuse me for a second while I grab a drink of water. And let's continue on. An airplane travels at 150 kilometers per hour for 2 hours in a direction of 138 degrees from Omaha. At the end of this time, how far south of Omaha is the plane? Well, first of all, let's go ahead and draw our coordinate plane. Next, let's go ahead and get our bearings or our directions. Now, you always start on the positive y-axis and you rotate clockwise like that. So we're going to rotate 138 degrees. So from here to here is 90, and then 48 more degrees, excuse me, would be 138. So I'm going to go ahead and put that angle inside the triangle right now. It's going to be 48 degrees because from here to here is 90, and then 48 more degrees, 90 plus 48 is 138 degrees. Now, how far, here's the airport, the plane took off and it's traveling through the air like this, okay? Now, how far has the plane traveled? Well, let's see. It's been in the air for 2 hours, flying at a rate of 150 kilometers per hour. So the first hour, it traveled 150 kilometers. The second hour, it traveled 150 kilometers. So far in 2 hours, the distance is 300 kilometers. Now, let me go ahead and extend this axis here. The question is at the end of this time, how far south is the plane? So all that I'm looking for is just one missing piece of the triangle, and it's this right here. I'm going to put S for south. So again, if I can draw this triangle off to the side, like I did in the last problem, put a right angle here, put 48 degrees here, put 300 here, and put an S here, I'm really all set, students. I mean, this is my angle, so this is my opposite side over here. This is my hypotenuse over here. This is my adjacent side up here. All that I care about is finding the opposite side, the south, the direction the plane or the distance the plane has traveled south. And I know the hypotenuse is 30, so I'm going to use sine again because I want to use the two sides, opposite and hypotenuse. So the sine of 48 degrees equals opposite over hypotenuse. Anytime you have a trig equation in which you're missing part of your fraction, you multiply both sides by the bottom of the fraction. Whether it's a number or a variable, it doesn't matter. In this case, the bottom of the fraction is a number, 300, so we're going to multiply both sides by 300. Now, we do not have memorized, we do not have special triangles for 48 degrees. So with your calculator, simply type in 300, and then hit sine, and then 48, and then close your parentheses, and hopefully you're in degrees. If you're in degrees, you will get 222.9, so I'm going to go ahead and put 223 kilometers south. So that's how far south the airplane is from the airport. These are really not super difficult problems, students. They're really not. Okay, now we're going to move on to page 488, number 61 through 69 all. So here we go. Number 61. They tell us we have an arc length of 8, a radius of 3.5, and they want us to find the central angle. Now the directions say, by the way, and let me turn over there quickly, the directions say Complete the table and round the answers to 2 decimal places. All right, here we go. We know the formula we're going to use is theta equals S over R. Now, theta equals S, arc length would be 8. R radius would be 3.5, or just simply 3.5. So with your calculator now, we're going to type into it 8 divided by 3.5. And if you do that correctly, you will get 2.29. They do want us to round to 2 decimal places. So really your calculator should say 2.285714, etc., etc. So we're going to round it to 2 decimal places like the directions say, 2.29 radians. Remember, anytime you get out theta using this formula, it will always be in terms of radians. All right, let's continue on and take a look now at number 62. Here we're looking for the radius. So we're going to use our formula, theta equals S over R. Now notice your angle here is given to you in degrees. And remember, you can never use this formula unless your central angle is in radians. So very quickly, we're going to change this by multiplying 45 by pi over 180. 45 does go into 180, so 45 goes into 45 once. 45 goes into 184 times. 1 times pi is pi, 1 times 4 is 4. So instead of using 45 degrees for the central angle, I'm going to use pi over 4. S is the arc length, so I'm going to put 200 for my arc length, and R, of course, is the radius. Now, anytime 2 fractions are equal, a quick shortcut is to cross multiply and set your products equal. So cross multiply, 4 times 200 would be 800, and then cross multiply pi times R, and that would give you pi R, and then set them equal. Now we're going to divide one side by pi, divide the other side by pi. These cancel, and we're left with R equals 800 divided by pi. Let's use your pi button on your calculator. 800 divided by pi. I just typed that in wrong. Hold on one second. And I'm getting out for number 62, 254.6479089. So we're going to round to 2 decimal places like we're supposed to. So 254.65, and don't forget we're in centimeters, so that would be centimeters. Sorry, that's so sloppy. 254.65 centimeters. Moving on to 63. Here we're looking for arc length, so we'll go ahead and use our formula. Theta equals S over R. Now for theta, notice your central angle is already in radians, which is good. So 5 pi over 12 equals, of course, S stays S. We're looking for the arc length. Radius is 4.2. Now, let's cross multiply. 12 times S is 12S, and 5 pi times 4.2 would be 21 pi. I just simply took 5 times 4.2, that would be 21, and then pi, so 21 pi. Now, we're solving for S, so we're going to divide by 12. Don't forget what you're solving for. We're not solving for pi, we're solving for the unknown variable S, so we're going to divide both sides by 12. Now, if we did that correctly, we'll finish it over here. S equals, and now with my calculator, I'm typing in 21 pi divided by 12. And I'm getting out for that answer 5.497787144. So I'm going to round to 2 decimal places, 5.50 inches. 5.50 inches, because my original length up here in radius was inches. All right, let's go ahead and move on and give number 64 a shot. All right, we are looking to find the radius. And by the way, students, listen to me. When you see this 5, you're thinking, oh, there's no pi with it, so it's degrees. No, no. If there's no degree symbol like this right here, if there's no degree symbol, it's radians. So this is already in radians for us, okay? So here we go. Theta equals S over R. Well, for theta, I'm going to put 5 radians. For S, I'm going to put 16. And then for R, I'm going to put R. Now, There's a couple of different ways to do this. I would just simply recommend you put the 5 over 1 and then cross multiply like we've been doing. So 5 times r would be 5r. 1 times 16 would be 16. Now divide both sides by r, divide both sides by 5, and when you do that, you should get 3.2, exactly 3.2 yards. So the radius is 3.2 yards. All right, number 65. They tell us that we have an arc length of 132 centimeters, a radius of 120 centimeters. Find the central angle. So the central angle equals S, 132, over R, 120. So with my calculator, let's go ahead and type in 132 divided by 120, and we get out 1.1 radians. However, it does ask, if you'll look at the end of number 65, it says how many radians and how many degrees. So we have found the radians, 1.1. Good. Now we got to convert that to degrees. So remember, anytime you have radians, you take it, put it over 1, you multiply it by 180 over pi. So 1.1 times 180 would give you 198, and 1 times pi would give you pi. So with your calculator, type in 198 divided by pi, and you will get 63.02. It's said to round to the nearest degree, so I'm just going to put 63 degrees. And there we go. There's your answer in radians. There it is in degrees. Number 66. We're looking for theta. All right. So we know theta equals S arc length, that's 20, over R radius, that's 10. Oh, it's not 10. They're trying to trick you. Did you fall for it? They don't give you the radius, they give you the diameter. Now here's a circle, and here's your diameter going all the way across. If the whole diameter all the way across is 10, then wouldn't the radius just be half of that? Wouldn't the radius be 5? Sure it would be. So any time that a diameter is 10, you know for sure that the radius would be 5. So I'm going to go ahead and put a 5 right here. All right. So theta equals 20 divided by 5. So theta equals 4 radians. Don't put a degree symbol there. It's 4 radians. Okay, for number 66. Now they want you to convert that to degrees. So remember, anytime you're converting radians to degrees, you multiply by, I'm not sure why I put an equal sign, you multiply by 180 over pi. Well, 4 times 180 would be 720. 1 times pi is pi. So I'm going to take 720 and divide that by pi, and I will get 229.1831181, so 229 degrees. So there's your two answers. One's in radians and one's in degrees. Number 67, we're looking for the arc length. So we have our theta is 1.6 equals arc length S over your radius 2. Now again, there's more than one way to do this. I would just simply put this over 1 and cross multiply. So 1 times S is S. 1.6 times 2 would be 3.2. So we're done. That's it. Pretty simple. S equals 3.2 yards. Next would be number 68, and we're looking for arc length again. So my central angle is already in radians, is 2.1 equals S over 5, your radius. Now, I would recommend you simply just put this over 1. You have two fractions that are equal, cross multiply. 1 times S is S. 2.1 times 5 is 10.5. So S, the arc length, equals 10.5 meters. 10.5 meters. And now, last but not least, they've thrown a good old curveball at you here, number 69. Through how many radians does the minute hand rotate from 1240 to 130? Now, you aeronautical engineers, this will be a good problem for you guys. Let's see if you can figure this out. All right. Wow, really nice circle there. We will try this one more time. There we go. All right, now the minute hand is going to start out at 1240. I don't care about the hour hand. It says how many radians does the minute hand rotate from 1240. So I'm going to go ahead and put a point here, and that's about 1240 right there. Slide this down to where it should be. And let's get some numbers on here. We know this is 6. This would be 7. This would be 8. And straight across would be 9. And then we have 10, 11, 12. And it says it's going to rotate from here all the way to 130. So I have my 1, my 2, my 3 is straight across, and then my 4, and then my 5. So here's where the minute hand starts. Now it says in the problem the minute hand goes from 1240 to 130. So the minute hand is going to start here, and it's going to rotate all the way until it gets right there. And now the minute hand is going to be right there, pointing to the 6. All right? So they want to know what that angle would be, the angle that goes from here. How many radians did it rotate from here, where my pin is, all the way to here? Now, come on, you aeronautical engineers. Let's think this through for a second. If you would have gone all the way around, that would be how many degrees? 360, right? Sure, definitely, you know that. So, let's kind of find the piece of a puzzle here. You traveled from the 8 all the way to the 6, so you stopped 2 numbers short. You could have rotated to the 7 and then to the 8. So this is a really hard problem. See if you can figure this out. So we rotated around 10 out of 12 numbers, right? Sure you did. So that would be 5/6 of the circle you rotated from here to here. Let me go with that again so I don't lose you. You went from here to here, and that's, you traveled from the 8 all the way to the 6. That's 10 out of 12 numbers you rotated. 10 out of 12 numbers, so that's going to be 5/6. So you rotated 5/6 of means multiply, 5/6 of the distance all the way around. Now the whole distance all the way around is 360. So I'm going to take 5/6 of 360. I don't want the whole 360. I want 5/6 of the 360. So of means multiply. 5/6 times 360. By the way, why am I using 360? Because there's 360 degrees in one rotation. So if you would have gone all the way around, that would be 360 degrees. But you didn't go all the way around. You only went 5/6 of the way around. So we're taking 5/6 of 360. Of course, 6 goes into 6 once. 6 goes into 360 60 times. And 5 times 60 is 300 degrees. Cool. So that's how many degrees you rotated around. Now, I don't know if it says to, oh, it does say radians. Okay, sorry. So we're going to go ahead and convert this now to radians. The problem does say how many radians did it rotate. So it rotated 300 degrees. So we know how to very quickly convert degrees to radians. You multiply 300 times pi over 180 and cross off a 0, cross off a 0. 2 would go to both of these. Actually, a bigger number would. Let's see, 6. 6 would go into both of these. 3 times 4, 18, and 5 for 30. So 5 times pi is 5 pi, and 1 times 3 is 3. You did it. 300 degrees is the exact same thing as 5 pi over 3. So what angle or how many radians did this minute hand rotate around the circle? It rotated 5 pi over 3 radians. Good job. Hope this has helped. Continue to work hard, students. And call me or email me if you have any questions or if I can help you.